here we have to given that the velocity v of a particle at a distance s from a point on its path is given by the following table. We have to given that here a distance and the velocity, okay, of a particle. Then from this data we have to estimate the time taken to travel 60 meters by using Simpson's 1/3 rule. Okay, here we have to find the time taken to travel 60 meters, that is from 0 to 60. That means we have to find the time taken. Okay, that is here we have to given at the distance, at 0 distance the velocity will be 47. That is we have to given distance and velocity of the particle, and from that we have to find the time. If we find the time taken 0 distance, then at 10 distance, at 20 distance, 30, and up to last 60 distance, taking their addition to get the value, that is the total time this distance. Okay, so we take that addition, that is to find by using the Simpson's 1/3 rule. Okay, so first for this, before that we know that the velocity, we know that velocity is equal to change in displacement, change in distance, that is displacement, divided by change in time. Okay, velocity, that is v is equal to, we write here v is equal to ds divided by dt. Okay, so v is equal to ds divided by dt, I write here. So we have to get equation v is equal to ds divided by dt. Okay, so if we take the integration on both the side, v is equal to ds divided by dt. So if we shift this dt here, so we have to get this equation becomes dt is equal to ds divided by v. Okay, so here we have to get the formula of change in displacement, that is change in displacement dt is equal to ds divided by v. Okay, that is dt. If we, that is here the derivative of time. If we take here integration of this term, that is on both the side, then we have to get the simply t, that is the time taken to travel 60 meters. Okay, so we take here integration, that is integration dt is equal to integration, so 0 to 60 ds divided by v. Okay, that is equal to integration from 0 to 60 1 by v ds, or we write this integration as 0 to 60 1 by v, consider y dx. Okay, that means integration from 0 to 60 dt is equal to, we get the integration from 0 to 60 y ds. Okay, so here y will be equal to, we have taken 1 by v. Okay, so if we find this integration 0 to 60 y ds, okay, then because we have to given here the displacement, change in displacement 0, 10, 20, 30 up to 60. Okay, and also at that time we have to get given that the change in the velocity will be velocity of a particle. Okay, so if we find value of y will be 1 using 1 by v, that is y is equal to 1 by v, we have to get the different values of y at these s points, that is we have to get the set of data points, and using the Simpson's 1/3 rule, if we find this integration, integral is nothing but the time taken to travel 0 to 60 meters for a given particle. Okay, so in this way, then here we first find the set of data points, so s we have to given that distance, then here y is equal to, we find 1 by v, because we take y is equal to 1 by v. So yes will be given that 0, 10, 20, 30, 40, 50 and 60. Okay, so when we find here 1 by v, we will be given that 47. So 1 by 47 we have to get 0.0213. Okay, then next value of v will be here 58. So 1 by v if we find, then we have to get 0.0172. then next we have to get 0.0156. then next we have to get 0.0154, and next at the 40 0.0164. then next we have to get 0.0192. okay, and last at the 60 we get 0.0263. 3. Okay, so using this function y is equal to 1 by v, here we have to given that the velocity of particle. Then using this y is equal to 1 by v, we find these all values, though we have to get this set of new data points, and using this set of new data points we find this integration, and we find this integration, that means which is nothing but the time taken to travel the particle from 0 to 60 meters. Okay, so we use here to find this integration by using Simpson's 1/3 rule. So integration from 0 to 60 y ds is equal to, here, okay, from this page, here we have to get the values of y. If we consider the values of y will be y0, y1, y2, y3, y4, y5 and y6. Okay, we consider values of y will be this. Okay, so using Simpson's 1/3 rule, we know that the Simpson's 1/3 rule will be h divided by 3 in bracket addition of extreme ordinates plus 4 into addition of odd ordinates plus 4 into addition of odd ordinates plus 2 into addition of even ordinates. Okay, so using this we calculate the integration. So h divided by 3 will be as it is, and here from this y0, y1 we have to get here, given the ordinates are y0, y1, y2, y3, y4, y5, 6. Okay, that is 7 ordinates. So extreme ordinates are y0 and y6. So first y0 plus y6. Okay, then formula is 4 into addition of odd ordinates. Okay, so here odd ordinates will be y1, y3 and y5. So 4 times in bracket y1, y3 plus y5 plus 2 into addition of even ordinates. So even ordinates will be even y2 and y4. Okay, so 2 times y2 plus y4. Okay, so in this way, then here we put the values of these ordinates. Okay, simply. So again here h will be, if we see here, s displacement will be, distance will be given that 0, 10, 20, 30 in this way. That is the difference will be difference in distance will be 10. Okay, which are equally distributed by the difference 10. So h will be here 10 divided by 3. Then y0 will be 0.0213 plus y6 will be 0.0263. Okay, plus 4 times y1 plus y2, 4 times y1 plus y2. Values of y1 plus y1 will be 0.0172, then plus y3 will be 0.0154 plus y5 will be 0.0192. Okay, and plus 2 times y2 plus y. The value of y2 will be 0.0156 plus 0.0164. Okay, bracket complete. And after this calculation, we have to get the value of this integral will be 1.0627. Okay, so we have to get integration from 0 to 60 y. Yes. Okay, but that is the integration from 0 to 60 d is equal to, we get 1.0627. That means taken to travel 60 meters by using Simpson's 1/3 is 1.0627 seconds. Okay, so This way we find the time taken to travel 60 meters of particle using Simpson's 1/3 rule. Okay. So in this way. Then we see the next example. Okay. So next example is evaluate log E log 7 to the base E by using Simpson's 3/8 rule. Okay. Here we have to not given the value of function. Okay. And also we have to not given the of data point. Okay, we have to only given that the log of 7 and using Simpson's relation from 0 to 6 1 upon 1 plus x dx. If we consider this integration, so if we take this integration of 1 upon 1 plus 6 will be log of 1 plus 6 and limits from 0 to 6. Then by putting here limits we have to get log of 1 plus 6 minus log of 1 plus 0. So we have to get log of 1 plus 6 will be log of 7 to the base e minus log 1 minus log 1. Okay, so we know that the log 1 will be 0. So we have to get here 0. So log 7 to the base e. That means integration from 0 to x 1 upon 1 plus x dx is equivalent to the value of the log 7 to the base e. That means if we have to find or evaluate the value of log 7 to the base e, that is to evaluate this integration from 0 to 6 1 by 1 plus x dx. Okay, so we divide here in interval will be, so divide interval 0 to close interval 0 to 6 to equal subinterval interval of length equal subinterval of length h is equal to 1. So we divide here the interval 0 to 6 equal subinterval of length, take h is equal to 1. Okay, so here x will be equal to 0, that is we take it as x0 0. Then we have to get x1 will be 1, x2 will be 2, x3 will be 3, then x4 will be 4, x0 0, x1 will be 1, x2 will be 2, x3 will be 3, x4 will be 4, x5 will be 5, x6 will be equal to 6. Okay, so these are the values of x. Then using this function y is equal to 1 upon 1 plus x, we have to find the values of y, that is y0, y1, y2 up to y6. We write that in next page. Okay, so write here the set of data points in this way, tabular form x and y is equal to 1 divided by 1 plus x. Okay, so add 0, 1, 2, 3, 4, 5 and 6. We have to find the values of y is equal to 1 upon 1 plus x. So if we put x is equal to 0 here, so we have to get value of y will be 1. Then by putting x is equal to 1 here, 1 plus 1 to 1 by 2 will be 0.5. Okay, put x is equal to 2, so 1 2 plus 1 3, 1 by 3 will be 0.33. Then next we have to get 0.25. Okay, 4 3 plus 1 4, 1 by 4 0.25. Then 4 plus 1 5, 1 by 5 that is 0.2. Then 5 plus 1 6, 1 by 6 will be 0.166 and x is equal to 6, 6 plus 1 7, 1 by 7 0.142. Okay, so we have to get these will be the set of data points. Okay, then using the set of data points we have to evaluate the integral from 0 to 6 1 upon 1 plus x dx, that is nothing but the value of log 7 to the base e. Okay, then by Simpson's 3/8 rule, we know that the Simpson's 3/8 rule is integration we use here for this integration from 0 to 6 y dx is equal to 3h. Simpson's 3/8 rule is 3h divided by 8 in bracket addition of extreme ordinates, addition of extreme ordinates into multiple of 3, 2 into multiple of 3 plus 3 into remaining ordinates plus 3 into remaining ordinates. Okay, so we write here the values. So y0, here we take this as y0, y1, y2, y3, y4, y5 and y6. Okay, so 3h divided by 8 in bracket addition of extreme ordinates, that is y0 and y6. So y0 plus y6 plus 2 times multiple of 3. So multiple of 3 here will be y3 and y6, but y6 will be the extreme, will be at right here. So here only 2 times y3 plus 3 into remaining coordinates are y1 plus y2 plus y4 plus y5 in bracket. Okay, then by putting here values h we here 1 because values of x will be distributed by the difference 1. So 3 by 8 in bracket we put here values y0 will be 1 plus y6 0.142. Okay, plus 2, y3 will be 0.25 plus 3 in bracket 0.5 plus 0.33 plus 0.2 plus 55 will be 0.166. The bracket complete. Then we have to get this calculation value will be 1.964. That is the integration from 0 to 6, 1 upon y dx. Y will be 1 upon 1 plus x and dx, and that is equal to the log 7 to the base e is equal to 1.964, because we consider this integration value of this integral is equivalent to this. Okay, so we have to get this in this way by using the Simpson's 3/8 rule. Okay, so in this way we find the integration, definite integration, that is in either trapezoidal rule, Simpson's 1/3 rule or Simpson's 3/8 rule. Okay, then we see the next example. So I write here example, evaluate integration from 0 to x dx upon 1 plus x square using trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule. Okay, we have to find this integral by using 3 rules. Okay, and we have to compare these rules, that is observe here. So f of x will be given that here 1 divided by 1 plus x square here, and the interval will be close interval 0 to 6. Okay, so if we take here h is equal to 1, then we have to get the values of x will be 7 values, that is we can divide this interval into 7 equal sub interval by the difference h is equal to 1. Okay, so from that we have to get the set of data points x and f of x at f of x will be equal to 1 divided by 1 plus x square. So first value of x will be 0, then by taking h is equal to 1 we get 1, x1 1, then x2 will be 2, 3, 4, 5 and 6, and using this function 1 upon 1 plus x square, if we put x is equal to 0 we get here 1. Then by putting 1 square 1 by 2, that is 0.5, then we have to get next 0.2, 4 plus 1 5, 1 by 0.2, then at 0.33 square 9 plus 1 10, 1 by 10, that is 0.1, then at 0.4 we get 0.588. Okay, at 0.5 we get will be 0.0385, and at 0.6 we get 0.0270. Okay, so in this way we find the set of data points. Okay, then we have to use these 3 rules to find the same integration. Okay, so we find that integration First, by using the trapezoidal rule. Before that, we write the value of y. These are values of y. It has y0, y1, y2, y3, y4, y5 and y6. Okay. So, using the trapezoidal rule first, trapezoidal rule, integration from 0 to 6. 1 divided by 1 plus x square dx is equal to h divided by 2. We know that the trapezoidal rule is addition of extreme ordinates. Here extreme ordinates will be here y0 plus y6 plus 2 times addition of remaining ordinates y1, y2, y3, y4 and y5. So simply here we have to put the values of coordinates. So h will be, here we take 1. So 1 by 2 in bracket y0 will be 1 plus y6 will be 0.0270. Okay, plus 2 in bracket y1 will be 0.5 plus y2 0.2 plus 0.588 plus 0.0385. Okay, here will be 0.0588. Okay, bracket complete, and by simplifying these we have to get the value will be 1.1, so value will be 1.4108. Okay, so using trapezoidal rule we have to get value of integral will be this. Then next, to find the value of integral by using the Simpsons 1/3 rule. Okay, so second, by using Simpsons 1/3 rule. So Simpsons 1/3 rule is for integration 0 to 6 y dx is equal to h divided by 3 in bracket addition of extreme ordinates. So here extreme ordinates will be y0 and y6. Okay, y0, y6. So y0 plus y6. Then by using 1/3 rule, y0 plus y6 plus 4 times addition of odd ordinates. So odd ordinates will be y1 plus y3 plus y5 plus 2 times addition of even ordinates. So even ordinates will be y2 plus y4. Okay, then simply we put here values. H will be here 1, so 1/3 bracket y0 plus y6. y0 will be 1 plus 0.0270, okay, plus 4 times 0.5 plus 0.1 plus 0.385, okay, plus 2 times 0.2 plus 0.0588, okay, 0. Here will be 0.385. Okay, bracket complete. Then again after this simplification we have to get value will be 1.3662. okay, so this is the value of integral by using the Simpsons 1/3 rule. Then last we find by using Simpsons 3/8 rule. Okay, by using Simpsons 3/8 rule. Okay, so integration from 0 to 6 y dx is equal to Simpsons 3/8 rule is 3h by 8. 8 in bracket addition of extreme ordinates y0 plus y6 plus 2 times multiple of 3. So multiple of 3 here will be only y3. Okay, so 2y3 plus 3 into remaining ordinates y1 plus y2 plus y4 plus y5. Okay, again we put here value. So h will be 1, so 3/8 in bracket y0 plus y6, that is 1 plus 0.0270, okay, plus 2 into y3. Value of y3 will be here 0.1 plus 3 into y1 will be 0.5 plus 0.0588 plus 0.0385. Okay, will be 0.5, then y2 will be, here y2 will be missing 0.2. okay, so bracket complete, and again after this calculation we have to get value will be 1.374. okay, so using the 3 by 8 rule we have to get value of integral will be this. Using 1 by 3rd rule we get 1.3662, and using the trapezoidal rule. okay, so see here, if we observe all the three rules, here we have to get value by using trapezoidal rule will be 1.4108, using these 1.3662, and using these 1.3734. that means we have to get the different values using the different rules of the given integration. that is, we have to get the approximate values. okay, today we solve the, that is to find the value of definite integral by using the 1 by 3rd rule, trapezoidal rule, or the Simpsons 3 by 8 rule. okay, so today we will stop here. Thank you.